Hi, good morning. Let's start today's class. Today is here. We are here, the final class of the final part of mobility terminal robot, humanoid, small humanoid robot, and other humanoid robot. It's a final four part is a final session of human robot interaction course. And what I want to inform you is next week. Unfortunately, I cannot be here because of my business trip. But the lecture class will be held as usual, and the Penchen will do some all of the sessions, and then you will come here and you should make some explain about your homeworks, and then do some Q&A session and the opinion exchanges. Okay? Yes, you should do on the next week class. But maybe the next week I will be able to hear about it. Yes. So therefore all the assignment and report you should do as usual. Also on the next week. Yes. はい。じゃあ please do. じゃあ let's start today's course, today's class. Today's class is mobility. Very wide range topic is here. The form, usage, function, problem, applications. Yes. Very wide range of questions, wide range of topics are included in this topic. So therefore, the many materials I have given and to the autonomous level, and also the test city, self-driving car testing city, and also the various applications, not only cleaning robot, but also the delivery service robot and so on. And yes, so therefore today's question challenge you have to consider before attending this class is first one is rect robot and field robot. Mobility, it will be roughly divided into two types, rect robot and field robot. So therefore, compare and examine the advantage and disadvantage of rect type robot and the field type locomotion. And the second one is various type of the mobility assist mechanism has been developed, and one of them is this one moonwalker. This YouTube is DW. DW means Deutsche Nantra. Deutsche, the public broadcast program provide this, and then please watch it, and the findings, your findings and the personal opinions, please give. It's the second question. And third one is a trolley problem, is a very traditional one. And so they explain and explore and explain the trolley problem, while considering the variations of the problem. Setting and listing the answer and options in each setting, and state your own answer, opinion to this. And discuss whether AI technology can solve the problem or not. This is presently a very interesting point. AI can help solve the trolley problem or not. And the fourth one is the technical issue of self-driving car. As we have watched the Waymo's case, Waymo's is the started public services on various cities in the United States, but we know that China already have done. And sometimes it's okay, but sometimes have some troubles. So therefore, the fact is the remaining technical issue for the self-driving car is what you want to consider. And when the accident happens, the liability or some guilty or duty, who has to own is the remaining problem. When the self-driving car will be more familiar and public used, public used. So therefore, explore and explain who could take liability to accident by a self-driving car while listing the responsible parties, responsible ones, and examining what kind of liability and why each party has to take that liability. It's the but these five is a very, very wide range topic. So therefore, yeah, what you have found, we want to know. But firstly, the time is limited in today's class. So therefore, which part you are interested in, we want to know. So therefore, which part you want to discuss today, I will ask you about it. So it's okay. The first is UA, which part you are interested in or which part you want to discuss today or something. Please explain your opinion. はい。ちょっと待って、you haven't contact to this, what? Not using the video, but to the, yes, you should make, yes, please do.
I want to talk about the question 4 about the technical issue of self-driving car.
Why you want to discuss?
Because self-driving car includes different kinds of AI technology to complete it.
Various what kind of technology is necessary to realize a self-driving car, you think?
The fusion of a sensor and AI algorithms.
Oh, yes. Sensing technology is one important point. Sense. And the decision making is also the one important technology. Yes, yes. I understand about. Yes, thank you. Thank you. The next, China, what is your opinion? Which part you are interested in or which part you want to discuss today's class?
Actually, I prefer the second part, the Moonwalker. This is an interesting design that I'm fairly interested about it. And also for my personality, I prepared some criticism for the question 3 that the AI ethical is just a wrong question that existed.
Wrong question.
Right, because it is existed ethical topic that it called about the slave and the master.
Like slave master
Right,
program.
right. So it could be a kind of stereology that it has already has a prototype. So we should talk about so the researchers about the aesthetics should talk about the prototype, but not the things that combined too much with the technologies.
But always the technology will be used for the people.
Right.
So therefore we don't we don't we don't consider not to concern about the ethical problem or the usage or something, of course.
Right. So we should concern about the new technology create some problem. However, this has a original prototypes that we have already familiar 1,000 years ago.
Yes, this kind of that question is remaining for so many years.
Right. Right. So we should try to think back toward the 2,000 years ago the slavery that not just think the AI problem, the AI aesthetic is a definitely new question.
Okay. Yes. Yeah. you want to hear the opinion or something?
Yes, I'm interested with the question four actually. The question four is about the AI technology used in the self-driving car, and uh, and I especially interested with the question that um about the explainability of the AI decision model. Because nowadays, with the developing of the self-driving car, there will be also some legal question. For example, if have some accident, uh, it it is the car's duty or the driver's duty, and nowadays, I just read a paper about that. Some researchers will let the AI model output the decision chain of the model, and I think this technology will help us to reduce the problem that about the legal duty legal problem. 以上です。
Explainable AI is the important technology to support the self-driving car.
Yes, especially on the legal question. For example, if have a accident, it is the car's duty or it is the AI's duty or the human's duty. 以上です。
AI duty と human duty と you have to you have to consider based on the explainability you have to take.
Yes.
Finally, please say something, which part you want to discuss today?
I prefer the question two. So I think the YouTube video in question two is very interesting, and the product move workers are quite a novel product, and I think it's very cool. But so when I think it's more carefully, I think this product also has many issues. So I think, for example, a big issue is the contradiction between the portability and the battery life. So because if the shoes want to be more have more portability, it means the shoes should be more lightweight. But if it needs to have a long battery life, means the shoes need to be more weight. So I think it's a big contradiction in this product. So I think the product also have many problems, but it's still a very cool product.
Okay, yes.
to fix accommodate to the demand, it would be a long distance between the existing technology to the actually need. Just like the Moonwalker, this product. It based for the last 20 meters for actually demand. However, it still has many difficulties to conquer. That's just like the price, the battery life, or just this kind of things.
Thank you. How do you think about the function about this kind of the actual demand or the something for the
Okay. I think that it is a good idea because before developing a project, the first step is to consider the demand of the user. Because if the user don't have the requirement, and I think the product will have better effect on the market, and maybe the production will be failed. So I think that consider about the requirement of the user is an important step before really developing. 以上です。
actual demand findings and also the difficulty of the making this decision about the demand or requirements for the product design or something. Yes, please, any comment on any aspect is okay about some finding demand, setting the necessity or the, yes, it is related to the product specification, of course. How do you think? Nothing? Yuri. じゃあ、ね、何するかっていうと、after the World War II in Japan, なんかメジャープロダクト、なんかメジャー、なんかカスタマープロダクト、コンシューマープロダクト。コンシューマープロダクトで、important one is, for example,なんか、ウォッシングマシンとかさ。ウォッシングマシンとか、あと、ライスクッキングマシンとか、次に TV かな。テレビジョンセットとか、あと、なんだカーだね。パーソナルカーっていうか、ファミリーカーっていうか、カー。とか、this kind of product, it's become popular ね。だけど、なんか、the other side of the product presently is for example,なんか、ウェルフェアプロダクトってあるよね。ウェルフェアプロダクト。for example, artificial limb とか、artificial arm とか、artificial arm とか、artificial leg とか、あるよね。だから、artificial hand とか、arm とか、hand とかさ、leg とか、あるよね。what is the difference between this consumer product and this type of welfare product? What is the difference? How do you think about this difference? Ifan, you have found something?
So the left side product can make our life better. All this product have is charming, and but it's really not necessary. So we can live without a TV, but the product on the right side it's really necessary. So if we without this product, we cannot live a good life. Yes.
Yes. So this kind of the washing machine, rice cooking machine, TV set, or the personal car is we can live without this product. So therefore, the demand level is not so high. demand level とか、requirement level とか、necessity level is not so high. But this kind of the welfare product, artificial hand or the leg, prosthetic is a very demand is high. The requirement or the necessity is very high.
Yes, I think the move workers in question 2 is also on the left side. It's not necessary at all, but I think it will sales very well if it can sales in China because many people will think this product is quite cool.
Yes. So therefore, I want to discuss about this kind of thing. Yes, many of them is this kind of a product is very easy to commercialize because this is mass product. Wide range of people. This is wide range of people wants to have this kind of thing. Demand requirement is not so much, but the many people want to have this. So therefore, the market is very wide. But this kind of welfare, the requirement is so high, but the very niche market. Niche. So very narrow and small sized market. Market size is so small. So therefore, this left side part is the large company wants to do this kind of mass product. The manufacturer wants to do this kind of the enterprising. But this niche product or this kind of the welfare is very supported by small company. Many venture company or the something small company is doing like this. Yes, personal engineer will do, and because not so many products cannot be solved. So therefore, this kind of thing, the different type of product is here. But for example, the cell phone, this cell phone, personal mobile phone has been commercialized. It's very large size and the heavy. mass. So the who will use it? So we don't understand the commercial, this size, the market size of this, but it becomes smaller and lightweight. So therefore, many users want to have this. Firstly, for example, this cell phone is very niche market, specialized small number of people want to have, because very busy person wants to have this. But this product will be changed into its size or the weight or the usefulness or something will become improved. So therefore, this product will change from the small market to the large market. So therefore, not only the type of product, but also the market size is also will be changed in some case. So therefore, the Moonwalker is presently the right size type product, but if it is become more useful, for example, the battery life or the weight.
Actually, it's even needed
Okay.
because it's product that has
Yes. Okay.
The price of it about $600 to $700, or because a product of a Chinese company, it's even less than $500, and even for the Chinese companies
Produced that it could sell more. However, it is actually an American company, so it sells about $1,200 as the inflation. So only limited people purchase it.
Price.
Right.
Price will be changed because of the production cost.
Right. For a company that contains better industrial productivity chains, every part of the product will be cheaper, and it could be more competitive. And if the competitivity is higher enough, it could makes actually the market just different.
Yes, so the production cost is very depending on the which country this product can be produced,
Right.
manufactured, and also the expecting market size
Right.
is also the important point to make some the price decision.
Right.
How many this product will be sold is also the important, and this product cost is make this decision about the price setting.
Right.
So various kind of factors will be changed, and making this kind of so this is a very difficult point. The price will, yes, cheaper is better, but the performance is also the important. Performance or this benefit. In other words,
Sure.
performance or the benefit is also the important.
The ratio of the performance and the price.
Yes. So this kind of the cost benefit ratio is very important. So that point is very difficult to decide or setting the product. So not only the technology supporting this product, the performance, but also this kind of part is also the important for not only, of course, the technology is necessary to make this technology. Technology is important to make this, supporting this product But not only technology, but also this kind of the cost-benefit ratio or something is the price decision or the concept of that product design is also the important point. Yes. Oh, yes. To concerning about this part, the Moonwalker is the interesting trials.
Right.
Yes, this is the American venture company has been doing this. But you found that they are very lucky. They are very lucky. Why I think they are lucky? Because they can do some trial and error
Right.
many times.
Right.
So the original product, second generation, third generation, fourth part, they have allowed to make the next product so many times. So therefore, they can do the try and error. Of course, the product will become better while repeating the try and error. But in many cases, they don't have much money,
Right.
and only once product produced. Try to marketize, but it will be failed.
And actually, I think the moonwalkers also have characteristics that it has already follows the definition of the robotics. The definition of the robotics is the goal of the most robotics to design machines can help and assist humans, replacing people in jobs they are boring, competitive, or unpleasant. Actually, for the working, it is just a kind of boring and repetitive job. So this follows the definition. It actually accommodates the original need of human beings. So it has a strong potential for their markets.
Okay, yes.
Unfortunately, even for that, so strong potential, the price of it is a little bit too high. If it's less than 60,000 yen, it could actually be more. I think it could be a wide and big market for it.
Yes, so this product is not human labor invasion, not to lose the human's work. So therefore only supporting,
Right.
yes, robotic product, but not only the autonomous usage, but only supporting.
Right.
Human is a main role とか main part, and this machine part is only supporting. So therefore, this kind of good. Yes, of course. Hi. Yes, that is very interesting. And yes, Ihan, how do you think about this? Is good enough for Moonwalker's discussion? What is your remaining part you want to discuss about the Moonwalker?
So I think the demand of the product beside the usability and the necessary the charming of the product is also very important, and I think Moonwalker is a very cool product. So I think it still can sells very well because it's very cool.
チャーミングね。アトラクティブっていうのは
Yes.
アトラクティブ part, the appealing point of some attractivity とかthis part is also the important. So therefore, the characterizing in some cases. So last week's この、 ラストウィークじゃなかったっけ？ラストウィークか。この、可愛い part is also the some charming part or the attractive part is the cute, pretty product is the also the another factor for purchasing some product. はい。じゃあ、that's about the question. これが question 4の part?question 2の part か。ムーンウォーカーパートだったけど。ちょっと待ってね。ここか。はい。question 2はおしまい。とりあえず。next, we should discuss which part. ペンチェン、which part you think we should hear from the students' answers?
Uh, I think we can talk about question 4 so they can exchange their opinion
Okay.
about
Self-driving car.
self-driving. Yes.
Yes, じゃあちょっと、we should hear from the students' answer about the self-driving cars technologies. What do you have explored and thinking about this self-driving cars technology? Self-driving, driving. car. はい。Yes, the Pension, please do some asking to others.
Firstly, Mr. Chen Yu, could you please share your considering about question?
Represent a revolutionary advancement in
Yes.
in transportation, yet they face significant technical hurdles that must be overcome to ensure safety, reliability, and widespread adoption. These challenges span perception systems, decision-making algorithms, and sensor reliability and cybersecurity. Perception systems, the ISO of autonomous vehicles. Perception is the foundational layer of autonomous driving, enabling the vehicles to interpret its surroundings. The system relies on a fusion of sensors, including cameras, radar, and ultrasonic sensors, each with distinct strengths and limitations. Cameras providing high-resolution visual data but struggle in low light or adverse weather conditions. LiDAR offering precise 3D mapping but faces challenges with long-range detection and high costs. Radar excelling in measuring object velocity and performs well in poor visibility but lacks fine-grained detail. Ultrasonic sensors useful for close-range detection, such as parking, but have limited range. A major challenge is sensor fusion, integrating data from multiple sources to create a coherent environmental model. Misalignment or sensor failures can lead to incorrect perceptions, risking accidents. For instance, Tesla's vision-based system avoids LiDAR but must compensate for camera limitations with advanced neural networks. Decision-making, the brain behind the wheel. Once the vehicle perceives its environment, it must make real-time decisions. This involves path planning, calculating optimal routes while avoiding obstacles, behavior prediction, anticipating action of pedestrians, cyclists, and other vehicles, action selection, deciding when to brake, accelerate, or change lanes. The complexity arises from uncertainty, unpredictable human behavior, or sudden obstacles. Current AI models, well advanced, struggle with edge cases. Waymo's decision-making stack uses predictive model to simulate possible scenarios, but no system is yet flawless. Control systems. The executor of autonomous driving. Once the AI determines the optimal action, control systems translate decisions into precise vehicle movements. This involves steering control, adjusting wheel angles with millimeter accuracy to maintain lane position, acceleration, braking, modulating speed based on real-time traffic flow and obstacle detection, adaptive cruise control, dynamically maintaining safe following distance using sensor fusion. The critical challenges lies in balancing ultra-low latency, sub-100 microsecond responses, fault tolerance, and smooth human-like operation, avoiding robotic jerks during emergency maneuvers. While Tesla's actuation systems demonstrate high reliability, icy road or sensor occlusion still test their limits. Cybersecurity, protecting against digital threats, as self-driving cars rely on software and connectivity. They become targets for cyber attacks. Characteristics include hacking, unauthorized access, what could disable safety systems or take control of the vehicle. Data breaches, personal location data collected by the car could be stolen. Sensor spoofing, fake signals could trick the AI into perceiving non-existent obstacles, ensuring robust inception, secure over-the-air updates, and intrusion detection systems designed to prevent catastrophic failures. Examine the contribution of AI technology to solve the perception systems. AI-powered perception systems enable autonomous vehicles to interpret their surroundings accurately. Convolutional neural networks are widely used for object detection, segmentation, and classification, ensuring the car can identify pedestrians, vehicles, and road signals. Semantic segmentation further refines this by classifying each pixel in an image, improve lane detection and obstacle avoidance. Decision-making systems. AI enhances decision-making through reinforcement learning, where models learn optimal actions via simulated trial and error. Macro decision processes help to predict outcomes and select the best action sequences, while behavior cloning trains AI to mimic human driving behavior used in real-world data. These techniques improve adaptability in complex traffic scenarios. Control systems. AI ensures precise vehicle control through model predictive control, which anticipates future states and adjusts steering and braking accordingly. Neural network controllers optimize the performance over time. Added feedback loops allow real-time correction, enhancing stability and safety. Generative AI rule. Generative AI addresses data limitations by simulating real driving scenarios and augmenting datasets with varied weather and lighting conditions. Companies like Waymo and Tesla use synthetic environments to test edge cases safely, reducing reliance on real-world data, challenges, and solutions. Despite advancements, challenges like edge case detection and sensor fusion persist. AI mitigates this through continuous learning and sensor data integration. However, issues like low light performance and ethical decision-making require further innovation. In conclusion, AI significantly advances self-driving technology by improving perception, decision-making, and control, while generative AI enhances training efficiency. Ongoing research is essential to address remaining challenges and ensure safer autonomous vehicles.
Right? That's all.
That's all.
The important point of your reporting, what do you think about the most important point of your talk?
The self-driving car consists of perception systems, decision-making process, control systems.
Okay. Consist of these parts is technology is further. What is the usual AI technology and the autonomous driving car usual technology? What is the difference? Is it same or some critical point is there? How do you think?
I think
Hmm.
the driving car mainly use self-driving car
Hmm.
mainly use end-to-end visual neural network.
Neural network has some problems. And it is similar to the other problems, other applications, you think? Anyway, it's okay. Yes, thank you for your.
Awesome. Could you please share your opinion?
Here I share my result. Firstly, the basic of it has already been introduced by Chen-san. And however, I'm willing to talk about that three main issues that the nowadays AI technology didn't solve them, however, make them worse. The first one is the perception under uncertainty. It described like the self-driving vehicles must navigate complex environments with imperfect sensor data. Situations like low visibility weather, occluded pedestrian or construction zones introduce the perception failure. This uncertainty compromises downstream planning and control. And the third, long tail generation and rare events. Each cases, unusual or rare traffic scenarios remains a core difficulties. AI models struggle with the situations not encountered during training, just as novel road geometries or non-normative human behaviors. And the third, the geographical and the cultural domain shift. A model trained on one region might underperform in another due to difference in road synergy intake or regulations. This raises the challenge of scalable domain adaptation for global deployment. Actually, these days, especially recently, the AI researchers are based on the end-to-end training, end-to-end models for the autopilot for the AI driving. However, it has already become a fairly problem for especially the long tail generalization and as well as the perception under uncertainty to cases. The first part is the long tail generalization. Because if we use some white box AI systems, we just for the AI for some cases to like the people to do some decisions and obey the regulations, it could be much more easier to be adjusted or doing something else. However, if we use end-to-end models to do the autopilot, it could be fairly difficult that we could not imagine all kind of long tail cases, and as well as the perception under uncertainty. Actually, when human driving, they are actually have already predicted some kind of uncertainty in many cases. They would obey some rules or some main functions, or even for the traditional regulations of uh, traditional common sense toward a kind of road traffic. However, when we using the end-to-end AI system, we could not imagine all kind of different unpredictable cases, and don't able to give the end-to-end system that this kind of reward. So this is that I basically talk about that recently AI research actually does some harm to the autocomplete. It would cause some severe problems that, as well as the 郭浩乾 says that the explanation of the AI should be considered. It's not just for the legal. It's also for the case for the long tail case.
Yes, yes. Yes. You are talk with that. Yes. Sensors performance.
However, for the drivers, the human drivers, they have terrible perception abilities that's in fundamentals. It's our eyes behaves terrible even in the midnight, even in low light conditions. However, we could still drive the cars safely. So I think it's definitely not the perception problem. It's just a kind of structure problem, a design structure problem. nowadays the perception system is really better than human beings. However, it actually not just a decision by the traffic itself, it also decided by something else, just for the common senses. So this is why I think the autopilot or the black box system for the autopilot would be actually, I think, a better way to solve this kind of thing. However, nowadays, autopilot always entering the black box system, and just the things they will never solve the long tail programs.
Yes, yes. この end-to-end モデルとか end-to-end training とか。Yes, presently, for autonomous driving cars training, the simulation, very, real-like simulation system, the 3D model has been used, and many cases is making the intentionally happens, and then to deal with this kind of happening or some cases, many researchers are trying to do this kind of simulator training. But the simulations environment is also some limitations, of course. But of course, AI systems, the most important point, most typical point is based on training data. So therefore, how to deal with the very brand new cases is
So this would be actually a very interesting case that's about just like my research, the symbolized robotics.
okay.
This kind of research that's using AI just for the initial generators that they give the predict to give a guess predictor or something that's not sure, and doing the experiments to examine the results to make their decisions. So the decision making is not just from the AI training system. The AI training system just gives some propose, and the examining system actually gives the result.
Okay. AI is only used for the propose something. Yes, choices, selections, proposing. Okay, but the decision making is a different system or different structure is necessary to.
It's using the basic
Okay. ディシジョンメイキングは different system. Some others will do some decision making. Only, AI is only propose or, propose or, なんていうかな、propose some, choices. propose か。はい。Thank you for your answering. Good. じゃあ next, ペンちゃん。
Mr. Guo Hao-Shen-Song, could you please show your opinion?
Oh, sorry. Explore and explain technical issues of the self-driving car. In addition, examine the contribution of AI technology so the have two tema about the question. Firstly is the prediction motion planning. usually is that anticipating what pedestrians or walkers will do next is complex. Edge cases like erratic cyclists or animal can trip up planners. Planning over high-speed dynamic environments requires real-time decision under uncertainty. And the AI rules is that behavior prediction network forecast trajectories using historical data and situation contexts. Um, Hybrid planning tools can be model-based and data-driven AI, handle real and evolving scenarios. And the second question is about the explainability of the regulatory compliance. Um, it is, it is that for the autonomous vehicles, AVs often operate as black boxes, making it difficult for passengers, regulators, and accident investigators to understand why a particular action like emergency brake or swerving was taken, and without transparency, it is hard to determine legal liability after an incident, or to ensure decisions comply with evolving safety and data protection laws. And how the AI can do for this question? Real-time decision insights, XAI tools like Silence apps, simplified surrogate models or natural language explanations can clarify which sensor input or rules drive a special maneuvers, and the regulatory agent by embedding XAI in AV systems. Manufacturers can meet legal standards like the EU's right to explain and provide post-incident reports that trust the AI's reasoning. Trust and the accountability. Explainable systems increase public confidence and assist users and regulators in assi- assessing whether the vessel acted appropriately or if a fault occurred, uh, enabling responsible development. And for these two questions, I found two papers to discussion about the point. And firstly is about the autonomous driving for the predict motion planning. Mm, yeah. And in this paper, the research developed a model in this structure. Um, Nowadays, many AI driving systems may just use the scan level feature, such as that such as that such as the for example, the picture taken by the camera of the car and make the decision. But for this system, the developers make a more complex system and try to solve the planner question. It is that they uh, firstly use four part. Firstly is the backbone. The backbone is meaning about the structure of the model and the perception. The perception, I think, is an interesting point in this paper. It meaning have the track former and the map former part. A track former is that um, the model predict how the car and the people will move in the future, and the map former is that the car the AI the AI detect what around the car and the feature will be used for the motion former. And the motion former is that predicts the movement of other cars and pupils in the future. And finally, according to this information, the car will make the own movement plan by the AI system. According to the paper, this system called Uni-AD actually better result. I think because this model consider enough information from the environment. But this is also have some disadvantage. The main disadvantage is the limitations and is meaning about that it require very extensive computation power. This is limited for nowadays because it maybe will make the car very expensive and is not affordable for many people. So it also needs some future work. And for the question two, the explainability, regulatory compliance, and I have this paper. I use this paper only for this part. In this part, the author gave us five points about the explainability of the AI model. First is the interpretability. It means that the user can know why the output how the input becomes the output. It is more like a white box system, and technically is about the explainability. It is that the AI system explain for themselves. Sorry. The explainability is that the AI system explain for themselves. For example, the DeepSeek have this method to explain themselves why they will make the generation. And technically is just feasibility. It is that the AI system's decision is justifiable if one can explain one output was good without necessary explanation how the output was computed. And then is the traceability. It is that we can see the decision chain of the phone decision-making process from the input to the output. It is more likely to the machine learning. For example, the decision trees, and secondly, and finally, is the transparency is a broad term that is often used to mean any of the above definitions. It is a more broad point, and 以上です。From other students, is there some questions to him? You have some asking some part. Okay.
To make answer prediction motion line for dynamic environment. This is okay. Maybe the other vehicles motion or the pedestrians the movement behavior will be estimated. This is commonly thinking about this kind of thing is the based on the sensor data, the pedestrian behavior and other vehicles behavior will be predicted. And based on that prediction, the own motion will be decided. It's okay. About the next part, explainable AI, not black box. There's some word you have explainable とか visible とか traceability とか transparency とか you said, but the facts actually fact. You want to inside of this word, yes, trace. But the AI's most one important feature is always updated experience based on this data. The AI is always updated, so therefore it is difficult to reproduce the past behavior is one important feature of AI, I think. So therefore, what is the meaning of tracer? But the one thing is most important is what is the meaning of explainability? What do you think it was? Explainable AI.
I think that the explainability of the AI is means that which feature of the input the output is depend on which part of the input. For example, in the autonomous driving, if a car decides to stop, what make the AI model decide to stop the car? Because the input have many features. For example, the car, the road, the people, and the explainability is meaning talk about which feature makes the car with the AI model make the decision. Is the car or the people or the road? It is the features. I think this is the meaning of the explainability.
Is the same as a black box.
Yes.
AI means inside this black box we can find something. So what is the meaning of the inside this black box explainability? This is my question.
For the if for the AI system, for the traditional AI system, just like the not the deep learning, it's for the just like have a reasonability of some object, some characteristics, and for each layer we could draw out that it's what it represents. However, for nowadays, the large models have we even cannot do something like this. So that is why I introduced a development method to create a white box. Well, not just say about nowadays AI directly do the we could not really do the explanation for the nowadays AI system, so we have to do something else.
All the type, several layers.
Right.
And
each layer have the representations of some characteristics. However, nowadays it's actually not able to extract them definitely. They have too much high high level vectors.
Too much complex layers, so
Right.
therefore it is difficult to find.
Difficult to get the to build the connections of the characters and layers that even human beings cannot guess what the each layer represent for.
Complex layer connection.
Just like the ChatGPT has billions of parameters, we cannot know each parameter what is the each parameter represent from represent to.
In Compton's paper, the causal chain とかなんか it has some word in his shown page.
However, actually, I think causal chain didn't get the actual. It's just a gray box. It's not a kind of white box. It is just actually a similar way that we I say to use AI to propose to guess and to examine because the causal chain actually still directly generates from the AI itself. It is not extracted from the structure, but extracted from the output.
Extracted from output. What's the meaning of this?
The causal chain is actually a kind of links that if we use the conversations toward a reasoning model, just like the O3 Mini or DeepSeek, it would do something just like it is thinking about something, and and we could find how they think. However, it is still a kind of output.
Yes, yes. So the explainable from this word explainable, I estimate that yes, many factors is considered, and the factor has some weight or this kind of condition that we can decide this とか
Right.
that kind of thing is the なんか reasoning とか reasoning of this decision
Right.
maybe. So therefore I'm expecting the AI to do this kind of explanation. So which factor they are considering. And then based on this factors, weight or the weakness, strongness, and something, and the mixture of this, and then decide this decision we want to know.
Right. Actually, the reasoning part is just AI, especially the chat AI that they gives the description of their decision process.
Yeah.
However, it is still a kind of output, so it still would facing the long tail problems.
Yes, long tail problem means the various kind of situations and
Right.
yes, for long time they experience various kind of the conditions, the situations, and depending on that condition, how to decide their decision is we want to know clearly.
Right. So I still regard it a gray box. It's not the definitely end-to-end black box, but we just could assume to guess how the AI thinking, but doesn't know how AI thinking.
It's thank you.
Thanks, Professor.
Thank you. How can okay? なんか explainable to what is explainable? We want to know more in detail. Not only the word reasoning とか word explainable, but also the what happened behind this word we want to know more. We want to consider more. Okay? はいはい。ちょっとじゃあ、finally, Ifan, please explain your the answer to this question.
I think the previous student has already covered most of my contents, and I just introduce this very briefly. So the technical issues of the self-driving car. So first, the safety remains a foremost concern. So nowadays, machine learning algorithm is very strong, but it's still not strong enough, and typically in the unpredictable or adversary conditions, and may lead to some accidents. And the second is that hackability is a critical issue. So I think nowadays many autonomous vehicles are using internet connected technology. And so, for example, a Chinese autonomous car brand named Naja. So this company, and once they update their cloud platform server, and there is some problems in this update, and it leads to all of the users cannot unlock their car, and some of their cars do not have the key, and only can unlock the car using the Bluetooth or the internet, and it leads to some users cannot unlock their car. So this is a problem by the company itself, but if it means if someone can hack their systems, it can uh, lead to some very severe results. And the third is the human AI handoff and partial autonomous rights operational risk. So in some situations, the partial autonomous still system still need the human to intervene. And however, some users may totally trust the AI and do not do anything, and it may lead to some accidents. And in addition, is the regulatory uncertainty worsens safety risks. And finally, the limitation in training data, software bugs, and decision-making transparency continues to affect the reliability of self-driving systems. And the contribution of AI technology to solve them. And the first is that AI plays a fundamental role in environmental perception, and they use the computer vision system to detect and classify objects. And the second is the AI drives sensor fusion, the process of combining data from cameras, LiDAR, radar, and the GPS to form a coherent 3D model of the environment. And thirdly, the AI enables prediction and planning. The fourth is the AI contributes to problem detection and safety monitoring. And the fifth is the AI is central to simulation and training. So finally, AI also plays a role in fleet level learning and over the air updates. So in conclusion, so while sales cars face unresolved technical and regulatory challenges, AI is not merely a component, it is an enable force behind their development. That's all.
はいはい。Happening problem is one of set in the in the autonomous driving car, of course. Yes, thank you. ちょっと time is only the 10 minutes remaining, so therefore I will show some my preparation for this answer. ちょっと待ってね。私は何を I have prepared for the question 4って。待ってね。これ question 1の話で、question 4。 これはトロリープロブレムか。If you watch some videos, for example, TED education video. 例えばこの4 major problem, self-driving car っていうのは、this is, I will copy to this chat box here. で、なんて言ってますかっていうと、コンピューターパワー、ソフトウェア、GPU サーバーパワー、とセンサープロブレム、データプロブレム、ロー、レギュレーションプロブレム。で、なんだっけ。ビジネスは、カーウォッシュ、ディテイリング、マシン、メカニクス、チャージング。なんかこういうところでビジネスあるよとか言ってました。これは this is the, なんかこの4 major problem は this video saying っていうのと、あとなんだここに potential problem self-driving cars この some law offices これいつのやつかなわかんないけど this site is saying that the workforce effect hackability safety autonomy problem それからなんだっけこの this, of course, this is injury 後に、この、it's also the same. Top 5 danger of self-driving car, vehicle crash とか、pedestrian accident, self-driving car, fire hazard, firing hazard とか、ハッキングプロブレムとか、ヘルスリスクもありますよとか言って、あとなんか、6 challenges of the autonomous vehicles, how to overcome them っていう this site is also saying that 6 problems, traffic management. この traffic management ね。this means that all of the cars will become the autonomous. It will be okay. Between the autonomous car, this traffic works well. But the mixture condition is very, very dangerous. For example, the autonomous vehicles and the driving vehicles, the human driver's vehicle is mixed situation is very, very dangerous because the human drivers will do some very, なんていうかな、dangerous action in some case. So therefore, this kind of mixed case is a very, very dangerous situation. And infrastructure っていうのは、これエレクトリックチャージングか。and revenue, liability とか、police ensure response とか、social justice and equality の part とか、in some cases っていうのは this is saying. Focus for research result issue future challenge. これどんなですかね I to explore this. I don't remember this. It's also the same. これは今、見つけられなかったんだけど、なんか、コミュニケーションチュートリアルっていうのを見れば、見つかるよとかいうことで。ここは愛かどうか知らないけど、これか。いいや、はい。ですね。こういうのもあるよっていうことで。Also for research result issues. これはいつですかと言ったら、this communication surveys っていうのはですね、いつのですかと言ったら、これもう more than 5 years ago なんで、ちょっと a little bit old, but this パートリクエストになっちゃった。ので、ちょっと今見えませんけど、このブラウザが悪いんでちょっとわかりませんけど、パートリクエストになっちゃった。なので、わかりませんけど、後で、later you should access to this site and get this. And also the others is also saying this kind of thing. まあ、イッシュ、プロブレムっていうのは、この4メジャープロブレムっていうのはここにあるし、and also、この Robust Sense っていうプロジェクト。これ、this is already finished in the EU project. The more robust, the automated driving in the self all environment conditions. So the sensing the hazardous っていうか very heavy rain condition situation, but the sensing must be secure. So therefore, this kind of sensing project is also has been done. Image in EICT っていうのも this is also the some countries the image processing project about for the autonomous driving car. And as I introduced, Waymo has started in Waymo Taxi has started service in the United States. So therefore, this kind of thing is very interesting. And but already some accident happens up to now. So this video is also interesting to watch maybe. ちょっと待ってね。まあいやいや、so therefore some accident happens, but they say it is less than the human accident, human driver's accident. So therefore it is become more safer than human driver, they say. Of course, not it is very difficult to perfect safety, perfect non-accident situation. It's no good. No, it is very, very hard to achieve, of course. So therefore, by using this kind of technology, some kind of accident will happen in some case. So, but we want to try to more try to reduce this kind of accident. This is today's final part. Yes. じゃあ、so therefore today is very, very the wide range kind of topic is included. So therefore, if you have some time in future, we will discuss more about for example, responsibility or liability when this self-driving car had some accident in some case. We should discuss more about it. But sorry, I will miss the next class, but the pension will do some management. So please do as usual. Right. Yeah, thank you for today. See you next time. Bye bye. See you.
Very much.